We're being asked in part A to rewrite a logarithm equation into a quadratic equation. How are we going to do this? Well, we're going to need to somehow combine the logs, and that is going to mean using our rules of logs. We've got that log AB is equal to log A plus log B. This is with any base. Similarly, log A divided by B is log A minus log B. And then the third one is that log A to the n is equal to n log A. So they're ready to use. And we can see we need to combine this into a single logarithm to be able to get rid of the log. First thing I'm going to do is bring that to, I'm going to use rule number 3 and bring that 2 up and write it as log 2x squared. And actually I'm also going to minus the log to base 2 kx minus 1 while I'm at it. You can do an extra step if you want. So I've used rule 3 and then I've also minused, because now I can use rule 2 and rewrite this as a single logarithm. It's going to be log to base 2 x squared over kx minus 1 equals 3. And this is great. This is what I want, because now I can undo the logs. It must be that the base to the power of this, so 3, is equal to x squared over kx minus 1. That's how logarithms work. I'm just undoing the log. If you're not too happy with that, then you might prefer thinking about raising both to the power of 2, and 2 to the power of log to base 2 sort of cancel out their inverses, and that again leaves us x squared over kx minus 1 equals 2 to the 3. Whichever way you want to think about it, this is the next line. We can now raise 2 to the power 3, which is 8, and multiply it through by kx minus 1. We're pretty much there. Just expand the bracket and then rearrange. I just say as required. Alright, we're then told that this logarithmic equation, which is equivalent to this quadratic, essentially, we need to be careful in a minute, but essentially it's equivalent, and it only has one real root. We're being asked to find this root. Well, that means we need to use the discriminant. So, sorry, I didn't actually label it, but that was part A. For part B, it must be that the discriminant, which is equal to b squared minus 4ac, is equal to 0. B is equal to minus 8k, so it's going to become minus 8k all squared minus 4 times 1 times 8 equals 0. Expand this out, 64k squared minus 32 equals 0. We can add 32 to both sides, then divide by 64. That's going to give 32 over 64. Actually, that is just a half. So we're going to get k equals plus or minus the square root of 1 over 2, which you could actually write as plus or minus 1 over the square root of 2. A little bit nicer. Okay, 2 answers for k. Now we need to work out what the root is. So case 1 is to consider k equal 1 over root 2. Now we need to find the roots. Well, actually, we can use the quadratic formula here, which is simply x equals minus b plus or minus. In this case, it's going to be 0 because the discriminant is 0. So it's just going to be minus b all over 2a. So it's going to become 8 times k all over 2, which is going to become, I can write it as 4 over root 2. Am I being asked to leave my answer in any particular form? I don't think I am. So yeah, I can simply leave it like that. You could rationalize the denominator, and then it would become, I could times top and bottom by root 2, it would become 2 root 2. Right, now we just need to check that that is suitable in the in this equation. So if I have k, which is 1 over root 2, and I times it by 2 root 2, that will still be positive here. 1 over root 2 times 2 root 2 minus 1. That will all work out. So I just need to check my solution. Because now we look at k equal minus 1 over root 2, and then x is going to equal, it's going to be minus b. It's going to be the same again, but I'm going to get minus 2 root 2. Now this works out over here, but now I get log of a negative. So when I said that these two equations are equivalent, they're not quite, because I'm allowed any values of x in this one here, unless I restrict them, which I didn't, but I should have. But here I'm not allowed to have negative x, for example. So I need to reject this one. Okay, and there is only one answer to this, 4 root 2, or equivalently 2 root 2.